Watch it shut down. It's going to shut down in like 2 seconds. All right. So let's start with, so we're going to go back to inequalities. It's been a while. What do you guys remember about inequalities? It's been months. Someone raise your hand. I'll just call stuff out.
There's like infinity answers.
Okay, there's an infinite number of answers, right? So keep that in mind because that's what a lot of what today is about, is those infinite number of answers. What else? There's one other main thing about inequalities we talked about. That was one.
Oh.
JJ's the only one that
When
remembers.
you flip the
When?
when you divide by negative
Or
times by negative.
there we go. Multiply or divide by a negative, you have to flip the inequality, right? So those are the two things. Just kind of keep those two things in mind as we talk about this. So a solution, this is the same thing as before. For an inequality, this is going to be an ordered pair that makes the inequality true. Or as we've said before, in math terms, we say satisfies the inequality. Right? So that's what it means to be a solution. So you plug in the two numbers, right? You plug in the x and the y. And if it's a true statement, it's a solution. And if it's a false statement, it's not a solution, right? We even practiced that. That was one of the questions on the quiz. So that's really the first thing we want to know, right? That's what it means to be a solution. So let's actually put that to use. So in our first example, we are going to decide if our ordered pair is a solution, okay? Tess, help us out. When we plug in 2, 5 to that first inequality, what do we get out?
You get 5 is greater or equal to 6 plus 1.
All right, so we can see we get 5 is greater than or equal to 7. Is that true? No. All right, that's all we got to do, right? That's a definite no here. Trish, do the same thing. Plug in 3, negative 7 to this other inequality.
You get negative 7 is less than negative 6.
Okay, negative 7 is less than or equal to negative 7. Is that true?
Yeah.
Yes. That was a yes. All right, that's all we got to do. We just need to be comfortable plugging things in, double checking that they work out, right? So 7 is, in fact, it's not less than, but it is equal to. So that one works out. 5 is, well, smaller than 7, so it just doesn't. All right, so what do all the solutions look like? We started class by saying there's an infinite number of them, not just one. And so let's look at that. So we want to graph, because that's how we're going to tell all the solutions. So we use a graph to do that. So we want to graph y is, let's go with greater than x plus 2. All right, the very first thing we want to do with this is we're going to plot the points like normal. We're not going to draw any lines yet, but we want to plot points like normal. Okay, so start there. So someone raise their hand and tell us, how do we plot the points? Not anything about the lines or anything like that, just simply the points. Judy, go ahead.
Wouldn't you go to the positive tail and then go up one over or down one?
There we go. How many points do we need?
2.
That's it, right? 2. So once you have your 2 points, you're good. Now, don't do anything else after that, right? So plot your points like normal. You only need 2 because for any 2 points is exactly one line. And then here's what we're going to do. We're going to look at the inequality. So if you have a greater than or you have a less than, we're going to use a dashed line. And the reason we're going to use a dashed line is because any number on that line is actually going to make a false statement. And so the dashed line tells us that there's no solutions on this line. All right, so we're going to have a dashed line here. Looks like that. And that tells us all the numbers on that line are actually false. So before we add anything else, let's just do a really quick check to make sure that that's true. What I just said is true. So this is the point. That ordered pair is 0, 2. So let's plug that into the inequality and see what happens just to check this. So you get 2 for y, you get 0 for x, so you get 2 is greater than 2. Is that true?
No.
No. And so that means every ordered pair on the line, you don't actually need to check that. Every ordered pair on the line is not a solution, so it's dashed, right? The dashed line tells us it doesn't work. But if we have greater than or equal to or less than or equal to, then we're going to use a regular solid line, just like we're used to. Because anything on the line itself will work. All right. So we're going to plot points like the normal, and then we pick, do we have a dashed line, do we have a solid line based on the inequality? But right now, we said there's an infinite number of solutions. Right now we have no solutions on the screen, right? Because all the ordered pairs that fall on the line are not true. So but there still are an infinite number. So here's the next thing we're going to do. We're going to end up shading a side, and that tells us the ordered pairs are true there. But how do we do that? So we want to shade a side of the graph, or side of the line. And here's how we're going to do it. So we're going to pick a point. We're going to pick what we call a test point to identify where do the true solutions fall or where do the false solutions fall. So in terms, we're just going to pick a point, any point, but we want to make it the easiest numbers to work with. What are the easiest numbers to work with?
0, 0.
Right here. 0, 0 is the easiest thing to work with, right? So we pick a test point, 0, 0, because it's easy, and plug that in. So let's actually check that. Plug in 0, 0 to our equation. We get 0 is greater than 0 plus 2, so 0 is greater than 2. Is that a true or false statement?
False.
All right, so then here's what we're going to say. If you get a false statement, so if you get false, if false, shade on opposite side. And then that would mean if it's true, shade on the same side. Now, what do I mean by shade? I haven't said that, so we're going to just I'm going to take a highlighter here. You guys are just going to lightly kind of scribble in with your pencils. And this area, all the solutions fall up here, right? And they fall up there because once again, we said, if you plug in 0, 0, you get a false statement. It does not work, right? That's false. That means every point on the bottom side of the line doesn't work. You can pick any one. If you held your pen up and dropped it on the bottom side of that graph, it doesn't matter where it fell, every point would be false. Same thing then if you held your pen above that shaded side and dropped it, any point it fell on, you plug it in, it's going to make a true statement. Right? And if you don't believe me, actually just pick some random point in the shaded area and plug it in, and it will in fact work. Right? And so we do that by using this test point idea, and that's going to tell you. Okay. Now I want you guys to use this during class, but I'm also going to show you a trick. So when we go over the example problems, we're going to do both. We'll check the test point, and we're going to use this trick. So, and this is going to be much easier to do. So I'll make a little note. If if the inequality is in slope-intercept form, right, that's the y equals mx plus b, or in this case, y is greater than mx plus b. So if it's in this form, y by itself, greater than or equal to mean shade above the line, less than or equal to mean shade below. This is a really nice thing to have, because then you don't actually really even need to think about it. So let's double check that. We have y is greater than x plus 2. We're going to shade above the line. It matches that trick. All right. So this is how we graph all of our solutions, right? There's an infinite number of solutions here. So then the next thing on your notes just simply says, what are these differences? So let's just make a quick note to ourselves. Oh, I'll just add it down here at the bottom of this page then. So our differences what are those? Like if you think about just graphing what you did on the chapter 5 test and what we're doing today in class, what are the obvious differences?
You shade it.
Okay. Differences, we're shading aside. Okay, that's 1. Luke?
They're like different lines. There's like a dashed line and then a solid line.
All right. Okay, so make sure that you guys just know that those are just 2 main differences that come up, right? So when you're thinking equations, you're just thinking normal lines, and now the second you see a linear inequality, you should be thinking these 2 things, right? You're going to pick a side to shade, you're going to have a solid or dashed line. All right. So we'll jump in to an example now, and we're just going to do a... All right, let's start with plotting points. All right. So Ms. Boo, help us just plot the points. What are the points I'm going to plot for 2x minus 3?
0, -3, and then you would go up to
Up 2 over 1. All right, those are the points, right? We only need 2 of them. Okay. And then Ms. Langer, what are we going to do for solid or dashed line?
draw a dashed line.
Dashed line. Looking something like that. Okay. And then Asher, are we going to shade above or below this line? Say it again, sorry? Above.
3.
There we go. Now let's just do a quick double check of that. We know it's above because it's greater than, but because we're just learning this today, we also want to check that test point to make sure that this is working out. So here's 0, 0. Let's plug it in. We get 0 is greater than 2 times 0 minus 3. 0 is greater than -3. That's a true statement.
Yeah.
If it's true, we shade on the side of 0, 0, right? So there we go. We're shading on that side of the line. Awesome. Let's do the same thing for this next line. Ellie, plot the points for us in 1/2 x plus 2.
2, and then
Up 1 over 2. That's all we need. For any 2 points, there's exactly 1 line. Ted, solid or dashed here?
Solid.
Solid. So it looks like that, more or less. And then Gigi, are we going to shade above or below? Shade below here. Once again, because we're learning, let's just plug in 0, 0, so it's right here, and let's make sure it works. So 0 less than or equal to 1/2 times 0 plus 2. So 0 is less than or equal to 2. Yep, so we shade on the 0, 0 side. Awesome. 2 more graphs to go to on the back side there. Intercepts here for part C. Ted, do you have the intercepts for us?
So -4, 0.
Okay, -4, 1, 2, 3, 4.
And then, and 0, -3.
Alright, these are our 2 intercepts. So far, so good. Harper, is this going to be a solid or a dashed line?
It's gonna be a dash.
And then remember, as written, so the way that this is written right now, you can't use just the greater than, less than, greater than or equal to, less than or equal to. Ashley.
Oh, yeah.
X should be -4, Y should be -3. These are correct.
yeah,
3.
that's what I got.
-4 for X, -3 for Y.
Oh,
These are good. Okay. So X is going to be 12 over -3.
You put in 0.
Y is going to be 12 over -4.
You divide.
Plugging, all you're doing is covering up the X, or plugging in 0 for X, plugging 0 for Y. Alright, so then deciding how we shade. Use your test point. It's really easy when it's in standard form, because when you plug in 0, 0, you always, in standard form, you will always get 0 on the left side, and then in this case we have greater than 12. Is that true?
No.
Definitely false, so then we shade opposite, because it's false, so we're going to shade down here. Right, opposite the 0, 0, because we've got a false statement.
Okay.
Alright, now somebody tell us the vertex point, just the vertex point, Alejandro, of the absolute value.
It is 1, 2.
2, 1.
2, 1.
Wow, you guys got kind of angry about that. So we're going to go up 1. The number on the outside tells us to go up 1. The number on the inside, opposite what we think. This is going to be right 2. Now somebody else tell us, how do we figure out, so it's a V shape. Is it skinny? Is it wide? How do we figure out what it looks like? Look.
It'd be 1, the slope would be 1 up over 1 because there's no like identifying like simple or like exact slope.
There you go, right? There'd be a number in front that would tell us, but in this case, it's not there. So then we just plot up 1, right 1, up 1, left 1. We only need 2 points, okay? Sam, is this solid or dashed?
Oh, it's dashed.
Dashed, because it's just greater than. And then finally, and this is y is by itself, so our trick works. JJ, shade above or below?
Above.
Above.
Like inside the thing.
Right here. And if you're unsure, you can plug in 0, 0, which is right here. You get 0 is greater than -2 plus 1. 0 is greater than 3. Is that true?
No.
No. So you'd shade on the opposite side.